Okay, we're going to continue on with Unit 1 and we're going to talk about significant figures. Now, significant figures can be very troublesome for students, but the more you practice significant figures, the easier they will become. Now, significant figures are very important in lab. So, on your lab reports, you always need to pay attention to significant figures. And if I ever write SF on your lab reports, it means you're not paying attention to sig figs. So sig figs are very important and very useful, and they tell us quite a bit of information. Now, another thing about significant figures before we get into the details of them. Your calculators are very useful, but they do not adjust for sig figs. So that's why we have to learn rules for sig figs and mathematical operations. So, there has not been a calculator developed as of yet that accounts for sig figs. So, all right. There are two types of numbers that we'll see in chemistry. There are measured numbers and exact numbers. So measured numbers you obtain when you measure something. So obtain when something is measured. For instance, your height, weight, all of these are examples of measured numbers. Distance, volume, and so on and so forth. Now, an exact number is something that you obtain, or is a number that you obtain by counting objects. So, obtained by counting objects. So, examples would be 2 bikes, 24 students. Also, conversion factors, which we'll get to later on in Unit 1. So, for instance, there are 60 seconds in 1 hour. So these are exact numbers. So, it's important with measured numbers that the quantity of digits expressed tells you something very different. For instance, it conveys precision of measurement when you're talking about measured numbers. So for instance, if you weigh a tennis ball on a bathroom scale, it comes up as 0 kilograms. If you weigh it on a laboratory scale, it comes up as 54.07 grams. If you measure it on an analytical balance, it's 54.07138 grams. Now, which scale would you prefer to use? Which tells you the most information? It turns out the analytical balance tells you the most information. And it's expensive to get all those digits. So that tells you that that balance is very precise. And those digits, to go that far, you need to have a very precise instrument. So, precision of measurement is indicated by the recorded value using all the digits known with certainty plus one additional estimated digit. So it's accurate to plus or minus 1. So with all of this measurement data for the tennis ball, the last digit is accurate to plus or minus 1. So that last digit is an estimate. So for instance, you could weigh this tennis ball another time on the laboratory scale and get 54.06 grams, and that's within error. And when we learn how to measure objects in the lab, you'll see this. So, The total number of digits used to express the measurement is called the number of significant figures. So significant figures, very important. Now there are certain rules with significant figures that we'll go into. For instance, this first measurement, 94.072, the number of significant figures it has turns out to be 5. So I'm going to put sig figs. So this number has 5 significant figures. This number here, 0.0834 centimeters, at first you might think it has 5 as well, but it only has 3. So 3, whoops. 0.02907 milliliters. Well, kind of going based off of the previous number, maybe these zeros don't mean what that they're significant. So it turns out that 0.02907 has 4 significant figures. So 4 significant figures. Now 138,200 meters, that has 6 significant figures. And then 23,000 miles has 2. So at this point it might seem like how I assigned the number of significant figures in each of these numbers might seem arbitrary, that I'm just kind of making up these rules as I go. On the next page we're going to go over the rules. So the first rule is that zeros in the middle of a number are significant. So zeros in the middle of a number are significant. So we see that with this first one. That is why we have 5 sig figs here. This 0 counts. Okay, the second rule is that zeros at the beginning of a number are not significant. Zeros at the beginning of a number are not significant. These are considered placeholders. So if you look at the second number, zeros at the beginning of a number are not significant. So we have zeros there, and we have zeros there. So these zeros are not significant. So based on that, 0.0834 has 3 sig figs. 0.02907 has 4 sig figs. Okay, rule number 3. Zeros at the end of a number after the decimal point are significant. Zeros at the end of a number after the decimal are significant. So I'm going to give you an example of rule number 3 right here. So if I have 138, let's use a different number actually. Let's do 139.9. This number has 4 sig figs. But if I write it out like this, so there are 2 more zeros after the decimal point, those count. They're not placeholders. So this number now has 6 significant figures. So if the zeros are after the decimal point, they count. All right, rule number 4. Zeros at the end of a number before an implied decimal point are not significant. Decimal point are not significant. So these last two numbers that I have, 138,200. There is 138,200. There isn't an implied decimal. It's not explicitly written. So zeros at the end of a number before an implied decimal point. So this is implied, are not significant. So I'm going to highlight those. And we have it also with this number, and then cross them out because they're not significant. So that's how I came up with 3 sig figs in this number and 2 sig figs in this number. So I want you to apply the 4 rules that we just went over and answer this question. How many significant figures does each of the following measurements have? So hit pause and work on those. Okay, so hopefully you got the same answers that I did. In A, there are 6 significant figures. And B, there are 2, because these zeros here are just placeholders. In C, the decimal point is implied, so there are only 2. And in D, there's a decimal point and then a 0 after the decimal point. So all of those zeros are significant, so their answer is 5 significant figures. So practice, practice, practice on significant figures. They will be very important in every aspect of this course. So we're going to learn conversion problems coming up in Unit 1. And the last thing you do before you write down your answer is count out significant figures. So practice, practice, practice. And it seems like these are just made up, they're not useful, but they are very useful. And trust me, if you know these rules really, really well, you will do well in this course. So, all right, moving on. We've talked about significant figures. We've talked about why they're important. Remember, with measured numbers, it conveys how precise a measurement is. Now we're going to learn how to do mathematical operations with significant figures. So this is very important as well. Now, I mentioned earlier that your calculators don't adjust for significant figures. So we have to learn a few more rules to adjust our answers to the correct number of significant figures. And if you practice these, you'll get them without a problem. So, how many significant figures would you have in this answer if you took 42.3 miles and divided it by 2.8 gallons? Well, some would say put all the figures you have, like whatever your calculator spits out. But you guys know that's not correct, right? 15.11, 15.1, 15. It turns out that the correct number of significant figures is 15. And I will tell you why now. Rule number 1 is for multiplication or division. So since we were dividing here, that's why we use this rule. And the rule is the answer cannot have more significant figures than either of the original numbers. Okay, so let's read through this again. The answer cannot have more significant figures than either of the original numbers. So let's look at the original numbers here. This number has 3 sig figs. This number has 2 sig figs. So our answer can't have more than 2 sig figs. So that's why 15 was used. If we used 15.1, that would have one extra significant figure. So this is for multiplication or division. Now we're going to address addition or subtraction. So I have this addition problem here, and then you can choose how many sig figs you would record in your answers. So they should all have grams after them. And you might try to apply rule number 1. But remember, rule number 1 only applies to multiplication or division. So it might seem that 7.04 would be correct. So you might be thinking between these two. And one of those is correct, and it turns out that 7.05 is correct. The reason is not the same as rule number 1. So let's go over rule number 2. Addition or subtraction. With addition or subtraction, the answer cannot have more digits after the decimal point than either of the original numbers. So after the decimal point, that's what matters with addition or subtraction. So think decimal point. So if you look, we have 2 after decimal point here, and then we have 4 after the decimal point here. So our answer cannot have more than 2 after the decimal point. That's how we came up with 7.04 or 7.05. Now, it turns out when you enter this into your calculator, this is what your calculator spits out. This is your calculator. And by the way, it's you will need your calculator for the rest of these notes. So probably having it handy to work through these problems will make it easier. And also for quizzes. So this is what your calculator spits out. It's not adjusted the correct number of significant figures. Unfortunately, your calculator does not do that. So we know that we need to have 2 after the decimal. So we need to have 2 after the decimal. So we're going to keep those 2, and the rest are going to fall off. But if you notice, this number here is pretty big. So we're going to round up. So that's why we got 7.05 as opposed to 7.04. So I'm going to talk about rounding next. So on page 8, I go over rounding. If the first digit you remove is 5 or less, drop it and all of the following digits. So if I take this number and want to adjust it to 2 sig figs, I'm going to draw my little bracket here. So I'm going to keep these on this side, and I'm going to drop these on this side. So it would be 2.4. Now, if the first digit you remove is 5 or greater, round the number up by adding 1 to the digit you're keeping. So if I want to adjust this number to 2 significant figures, I'm going to put my little bracket here. To the left are the digits I want to keep, and to the right are the digits I want to drop. So this number is 8 is definitely greater than 5, so greater than 5. So what I'm going to do is add 1 to this number 5 and drop everything else. So 4.6 is the correct answer. And then I'll drop these and I drop these. So I want you to do some rounding practice. I want you to round each of the following numbers to 3 significant figures. So hit pause and round. Okay, so this first one's pretty straightforward, right? You draw your bracket here, and this 9 adds up, so that's 201. That kind of makes sense. Now the second one might be throwing you for a loop. A lot of students say, well, 2 is less than 5, so I'm just going to drop it and put this. But think about this in terms of money. If I owed you $1,342 and I gave you $134 and I said, we're even. I don't see any problem with just giving you $134. I think you'd be pretty aggravated with me. And, likewise. $134 is nowhere near $1,342. So what we need to do is put a 0 there. So how about this? If I gave you $1,340, might call it good, right? Oh yeah, $2. Just buy me coffee in a few weeks, something like that. So when you have a situation like this, you need to put a 0 as a placeholder. So remember that 0 is before an implied decimal. So this does have 3 sig figs. What you don't want to do is put a decimal, because then that means it has 4 sig figs. So 1340 is the correct answer. Okay, this number, 0.000325689. Round it to 3 significant figures. Now remember, these zeros are just placeholders, so they're not significant. So I'm going to have to go here, put my bracket. So 0.000326. That has 3 sig figs. Okay, 499.6. So that would be 3 to the left of the bracket that I'm keeping. Now this is 5 or greater, so that's going to make this 9 go up to 10, which will make the next 9 go up to 10, which will make this go up to 500. So that's 3 sig figs. And then the last one, 3 sig figs. So it's helpful to think of this in terms of money. You might be thinking 423. But again, if I owed you $42,251 and I just gave you $423 and said, oh, we're good, don't worry about it, you'd be pretty irritated. So, but if I gave you $42,300, you'd be much happier. So these are before an implied decimal point. They're not significant. So you just have 3 sig figs. Okay. So the next page is more problems involving significant figures and mathematical operations. What I want you to do is hit pause and work through these and think about what we learned with rounding, and then think about the 2 rules that we learned, the multiplication or division rule and then the addition or subtraction rule. So hit pause and work on these. Okay, so I'm going to put what your calculator spits out in green, and then we'll adjust it together. So when you enter this into your calculator, you get 42. But you have to adjust it for the correct number of significant figures. And remember, the rule is, with multiplication or division, your answer cannot have more significant figures than either the original numbers. So 3 just has 1 sig fig. So our answer can only have 1 sig fig. So you get 4 as your answer. Now, is that right? If I owe you $42 and I give you $4, do we call it even? No. So you have to put the 0. So 40 is adjusted to the correct number of significant figures. All right, number 2. Again, I'm going to put what your calculator spits out in green. You get 17.36. Your calculator's not that smart. It has not adjusted for sig figs. Now this is addition, so we have to look at after the decimal point. So here we have 2 after the decimal, and here we have 1 after the decimal. So our answer can only have 1 after the decimal. So our answer, since the 6 is definitely 5 or greater, it's going to round 3 up to 4, so it's 17.4. All right. Our calculator spits out 4.6 for number 3. This is multiplication or division, so our answer can't have more significant figures than either of the original numbers. So we can only have 1 in our answer. So then 4.6 rounds up to 5. That's just one significant figure. All right, number 4, addition. So our calculator spits out 52.32. We have to adjust this for the number after the decimal point. So we have 1 after the decimal point here, 2 after the decimal point here. So we can only have 1 after the decimal point here. So 52.3. All right, number 5. Put this into your calculator and you end up with 6.3805. This is addition, so we have to think about the number after the decimal point. So we have 3 after the decimal point here, 4 after the decimal point here, so we can have 3 after the decimal point. So we end up with 6.381. And then the last one is multiplication or division. It's division, so we get this from our calculator. So our answer can't have more significant figures than either of the original numbers. So this one has 3 sig figs. This one has 4 sig figs. So our answer can't have more than 3 sig figs, and so these zeros don't count. 1, 2, 3. So then we get 0.01. The 7 rounds the 9 up to 10. The 10 rounds the 4 up to 5. So we'd get this. Now, if you carefully look at this answer, it only has 2 sig figs. It needs to be expressed to 3 sig figs. So we need to add a 0. So there you go. So practice, practice, practice. There is a nice pre-lab that goes over multiplication, addition, division, all the different operations involving sig figs. So work on that, work on your pink book, and work on your homework problems. So the next lecture, we will start with conversion problems. So work on the homework problems that we've gone over, and I'll see you again online.